everyone. Today we're going to start with lesson 2.1, the endocrine system. And our objective for today is that students will be able to discuss the effect of the endocrine system on behavior.
Okay, so in order to understand the endocrine system, we have to understand the nervous system and how the nervous system works. Your nervous system is broken into two. The first is going to be the central nervous system, which deals with your brain and your spinal cord. The second is your peripheral nervous system, which consists of the sensory receptors in your muscles and glands. So this is where glands especially is where our endocrine system comes into play. Your peripheral nervous system is then broken into two. The autonomic, so things that happen automatically, and somatic, things that you can control that are voluntary. So somatic might be something like running, right? I'm physically running, I'm moving my legs, I'm moving my arms voluntarily. So that's going to fall underneath the somatic division of the nervous system. Autonomic, though, there's a lot of things that happen in your body that happen automatically. Things like your heart beating. So there's a lot of things that happen in our body automatically, and that will fall underneath the autonomic system. Things like your heartbeat would be automatic. Things like digestion. You don't think about digesting food, that just happens automatically. Things like your glands working for the endocrine system, for example, that would all be autonomic. Underneath the autonomic, you also have the fight or flight response. And this is what helps our body in times of stress. So when I see sympathetic, I think sympathetic stress, SS. So let's say you're walking and all of a sudden you see a mouse. You scream, you jump, your heart starts to race a little bit because you're not a big fan of mice. That is going to be your sympathetic nervous system that's going into effect. So it's preparing your body for an emergency situation. Now, in this case, it's just a little mouse, so there's no need to have an emergency situation, but the sympathetic nervous system still gets triggered. Your sympathetic nervous system cannot go on for long periods of time. It can only go into effect for short periods of time, or else your body will eventually give out. And this is where we start to see people get sick because of stress. And so you have the parasympathetic nervous system, which is our calming nervous system. So after you see the mouse, your heartbeat increases, you realize there's no really threat, then you'll start to feel your heart decreasing. If you got really, really scared, you may notice that you're also a little bit shaky, and that's because of the adrenaline leaving your body, and it makes you a little bit shaky. The central nervous system, remember the brain, the spinal cord, and then that goes into our neurons. Our central nervous system is made up of what we call neural networks. And neural networks are clusters or groupings of neurons that allow for short, fast connections. So as your brain is sending messages to the rest of your body, it's going to use these neural networks to send those messages, and they're going to be very short, very fast, very quick messages that get sent from your brain to, let's say, your hand to remove your hand from a hot stove. It's going to be very, very quick. So the spinal cord connects to both the central nervous system and the peripheral nervous system. So the spinal cord is what is responsible for connecting our central nervous system to our peripheral nervous system, which is our neurons. How this happens is in the spinal cord, we have what we see as sensory neurons and motor neurons. So if you touch something hot, the skin receptor, so this is part of your peripheral nervous system, right? The skin receptor is. So you touch something hot. Once you touch that hot item, that sensory neuron, so the red one, the sensory neuron sends the information to the brain. The brain then tells you that is hot, you need to move your hand. So now we see what we have, the motor. So we see the motor neuron then sending the information back down to your finger, to your muscle, to move that finger away from the hot item. This is an example of a reflex. A reflex is an automatic response to stimuli, and it shows us how the central nervous system is related to the peripheral nervous system and how those two things are connected. So it will start with the central nervous system. No, I'm sorry, reverse that. It starts with your peripheral nervous system with a sensory receptor that then sends the message via sensory neurons to the brain, which then uses an interneuron, which connects the sensory neuron to the motor neuron, and then the motor neuron sends it back to the muscle to move. So we can go ahead and write that process out here on the bottom. So you have a receptor to sensory neuron. Sensory neurons are going to be part of the peripheral nervous system. Sensory neuron to the brain, and then an interneuron. The interneuron connects the sensory neuron to the motor neuron, and then the motor neuron tells you to move. The autonomic nervous system. So again, this is automatically. What is happening to our bodies automatically. If you are in fight or flight, to the left is what you see happen to your body underneath the sympathetic nervous system. You are going to have, so if you see this mouse, right, your pupils are going to dilate, your heart is going to increase, your digestion is going to stop, your liver and glands are going to, your liver is going to release glucose, which is sugar, to help give you some energy or an energy boost. Your adrenal gland is going to release adrenaline. So this is what's going to happen to your body when you see that mouse or if you're scared by something. You go into that sympathetic nervous system. You cannot stay like that forever. So then you have the parasympathetic nervous system, which is over here. And this is where it brings your body back to normal or calms you down. So your pupils go back to normal, your heartbeat slows, your digestion starts up again, so on and so forth. So sympathetic stress. When you're under stress, this is what happens to your body. The endocrine system. The endocrine system is the system that we use to help send messages throughout the body. So these are what we call chemical messages, which is part of your nervous system, and it's sent through the bloodstream. And it can influence things like hunger, aggression, and interest in sex. There are a few glands that you need to be aware of and what they do. The first is your adrenal gland, the adrenal cortex right there. This is responsible for, we're going to write it over here, norepinephrine and norepinephrine, also known as adrenaline. We use this during our fight or flight. So epinephrine is what stimulates you to increase your heartbeat. The norepinephrine is what calms you back down. The second gland that we're going to focus on is our pituitary gland, which is located in your brain. And your pituitary gland is what is known as your master gland. It's the most influential. So it's going to start with your pituitary, and then the pituitary will send the message to other glands because it's located in the brain. And the final gland that we're going to talk about is the pancreas, because the pancreas is responsible for insulin production. And this, if impacted, or when your pancreas doesn't work properly, that's what leads to diabetes. Okay, so this is how our glands impact our behavior.
So, like I just said, this is how our glands impact our behavior. So, understanding the nervous system and how it's divided into our central nervous system and the peripheral nervous system and the basis of how that functions helps us understand that glands are a part of that system. They are chemicals that flow through our bloodstream that help pass important messages throughout our body. So, things like we're hungry, or even things like we are, angry or upset, those are all being passed along by our endocrine system. Most importantly, out of all of those glands is going to be the pituitary gland, which is our master gland, that is the one that is responsible for sending the messages to all of the other glands.